So guys, as you can see, we are right now in our question paper, which is of 7th July 2024. That is the last term. So now let's move to our MLP section. Now let's understand few things here before starting the question paper. Total number of questions that you have to attempt is 14 and number of questions given is also 14. Section marks is 50. If you have taken subject, click yes. So let's see what our first question says. Consider the following common data and answer the given sub-questions. Here you have this code, panda, import panda is pd, import numpy is np, and column and data is given. But you don't need to worry about all this, just go to a question. So it simply says print np.sum df.shape. So you know that df.shape will return us row times columns, right? And np.sum basically adds the rows and columns. So all you need to do is figure out how many rows are there and how many columns are there. So let's look at this. So here it simply says columns 1, 2, 3, 4, 5. Rows 1, 2, 3, 4, 5, 6. If you add them up, what you will get? 5 plus 6 is 11. So that's your answer. Okay. And one thing to note here is that this double bracket, wherever you see now, it means that the values are in row wise order. So these are the different rows. And the reason for this is because it is a 2D data frame with column name as these. Okay. So now let's move on to the next question. It simply says what will be the output of the following code snippet? df of year of purchase dot value counts print t007. So you know that this is the column name. So we are accessing the column name year of purchase or YOP dot value count. Value count gives unique value counts, right? So that's the thing. Now let's move on to our year of purchase. You can see 2007, 2007, 2012, 2018, 2014 and 2007 again. So you need to find out how many values are here. Print T2007. So 2007, as it is a value count, so that means that it will be a dictionary where the key will be the value and the value will be the count or occurrence of the data. So 2007, how many times it occurred? 1, 2 and 3. So that means your answer is 3. Let's check if we are right or wrong. We are right. So that means that we are good to go. Now next question, print df.describe.t.shape 0. So here you again need to split your question. df.describe will return summary stats, right? But how it returns? It returns in this particular format. Remember? This is our row value 1, row value 2, and these are our summary stats, min, median, mode, something like that, right? Now, if you take a T, that means you are transposing the data. So your row becomes columns and columns becomes rows. So this data gets converted again to this particular data. Here our rows and here our summary stats, that is like min, median, mode. So now all you need to know is that this row, what was here, gets translated to columns. So you just need to find the number of columns in this. But one thing to note here is that describe actually works only on numerical data. So how many columns we have? Numbers. So we have numbers in one column and two columns. So that means only two columns will be the answer. And what are those columns? First one is year of purchase and second is price in lakh. So you can see that the answer is 2. Okay. After that, what will be the output of following code snippet? df.query year of purchase greater than equal to 2008 and fuel type not equal to petrol. So let's first break down the query itself. So it says greater than 2008. So 2008. So that means 2007 we can't use. 2012, 2018 and 2014. Okay. So 2018, 2014 and 2012. So that's good to go. Now fuel type is not equal to petrol. So here if you see not equal to petrol means it should be diesel, right? So here it is petrol, so we cancel this. We have this as diesel and this as diesel. So that means we have two values. Let's see, we have two values as answer, right? Question number 138. Now it says given data, which of the following option will provide the same output? So here if you see df.ilog3 year of purchase. So remember ilog starts the index from 0 and this first value will be actually the row index and year of purchase will be our column name. But since we are not using it within ilog, so that simply means here access third row index of column year of purchase that I am writing as YOP. Okay, so this will return the same result as this, because we know that loc also allows us to do row indexing. Here we are passing the row index, and now you can use the name of the column for accessing that particular column. So this means that this is again the column name, so it will also return us the same thing. Now if you are using ilog, then you need to be a little bit careful, because you can't use the name actually, so you need to use the column index. Again, column index also starts from 0, so let's start counting year of purchase in our data, which column it comes. Okay, 0, 1, 2. So this is the second column index. This second column index we can directly access. Again, it will be third row indices and second will be year of purchase. So again, this marks to this. Okay, now df.ilog -3, 2. Now some of you may see this as not an option, but it is not true. Let me tell you why. Just see the data. You have 1, 2, 3, 4, 5, 6. 6 values, right? And if we go from the negative indexing, that means -1, -2, -3. So this will act as -3. So this is a middle value. So -3 row index will work, right? As we are in ilog, and 2 and year of purchase. Now this is the very important one, because some of you may not take this one and you may lose some marks. So here what we are doing to do is we are trying to filter things. So again, rather than looking at the entire code and getting intimidated, just look at what is the condition that it is saying and first return that value. So df price in lakhs greater than equal to 10.0. So you have to find such a value where price in lakhs is greater than 10 lakhs. Okay, so let's check our data if we have some value. Yes, we have only this value, right? So this particular row indices, which is the third row indices, gets returned from this filtering condition dot year of purchase ilog 0. So year of purchase means YOP again, and ilog 0 means the first row index, which is the only row index we have. So that means it will again return us the same thing, because we are accessing the year of purchase column, and all options provide different output. That's wrong. So these are the kind of tricks that they apply on this particular question. Now let's look to question number 139. So here, if you would like to see more frequent car manufacturers in data, which of the following can be used? So it says most frequent, right? So frequent means count and most means highest. So there are many methods, but what we are going to do is very simple. Either we can take the value count, which returns us the unique values, and do the manual inspection for the count, and another thing is you can use group by. So we will group by manufacturer. So here this particular data will get transformed to Maruti, Hyundai, Toyota. Then we are accessing the fuel type column of it. So we will access this particular column, and after that we are taking the count. So since we are accessing the fuel type column and then we are taking a count, that means fuel type will be either diesel or petrol, and then we are taking the count value. So count refers frequency. It will also say us the same thing, and now we can again do visual inspection and find the most frequent one. So this is also right. Now here we can't do this because it says most frequent car manufacturer. So that means this is our main aim that we want to access. Okay. Now 140, which of the following choices are incorrect? Null values cannot be interpreted by model, hence we need to handle them accordingly. That's why data pre-processing steps comes from. This is pure theory. I hope that you know already these things. Still, let me give you a glimpse. It simply says that if you have some data, say 1, 2, 3, 4, 5, 6, 7, 8 and null. So this null value model will not understand. It requires all the data that you have so that it can work out its magic. Okay, and then null values cannot be replaced because we cannot manipulate them. Then what is the point of doing this? So this is wrong. We should let the SQL software automatically decide how to handle kind of missing values. No, we need to define the method that we are going to apply. So this is also wrong. Different types of representation of missing values could be seen in dataset. Now I don't know why this particular thing is right. It may be because we have our categorical data and numerical data. But my point here, why I am saying this wrong, is because it says missing values. Now if you see carefully in this data, you don't have any missing values. Here if they say that it is a missing value, then where is the name of the column here? It is not even there. So that means that it can't be a missing value. But whatever, I don't know how they are doing this, but I will not take this particular option because it doesn't seems right to take this one. However, you are open to take it if you like. Okay. Now, which of the following options are true about Pearson correlation matrix? So, correlation coefficient value in a matrix are in a range of -1 plus 2 plus 1. So, you all know that Pearson correlation coefficient actually comes from the stats itself, and value ranges from -1 to +1, and -1 means highly negative and +1 means highly positive. So these are kind of relationship. Okay, higher correlation coefficient among the feature leads to better model prediction. No, not always, because higher correlation coefficient means lot of dependency in defining our model. So if we have dependency, model may learn to predict, but it may overfit. That means that it would predict on trained data very good, but at test data or validation data it will perform very poor. That we don't want. We want to generalize our model, so that's wrong. Correlation matrix can be represented graphically using heat map. Yes, this is right. Heat map is basically a matrix represented with colors. Let's say we have blue, green, yellow, and these colors defines intensity of the correlation. So that thing is also there. So make sure that you understand that. And correlation coefficient value in the matrix could be in range of -infinity to +infinity. So this is wrong because we already know that our first option is right. Now 142. Which of the following method come under scalar model selection module? So grid search is because we are actually handling model parameters here, and stratified shuffle split also comes under this modeling only. Okay. Now mean absolute error and trees. These are not even methods. These are actually APIs, and trees is just a class. Column transformer comes from pipeline, and pipeline also comes from pipeline. So these are wrong. Okay. So only grid search CV and stratified shuffle split is right. Now, we need to process the data before using it for the model building due to which of the following reasons? Due to errors in data capture, data may contain outlier missing values which may hamper the model training, and so we need to handle it, right? Different features may have different scales. Yes, that's why we have feature scaling. Data contains non-numerical features, as we have seen earlier also. We have categorical data, so we need to somehow convert into numerical so that model can understand easily. So all of these will be the answer. Okay. For now, we will skip this question, skip 146, 147, 148 and 149. Question number 150. Question says which of the following can be used to get simple imputer object. Again, this is from this particular function. So here they are saying that we need to access the simple imputer object. And if you look at this particular code now, you will find that we have pipelines and then column transformers. So please refer to my last video where I have explained what is pipeline, what is column transformer, how we can use it. And one thing that I missed there was that you can access individual values within a pipeline using the list indexing or just calling the method name that you have defined earlier. Okay, and since we are accessing simple imputer, so we can directly access it using either impute method or using the index 0 because it is at the position 0. Okay, let's check what are the options. Impute scale wine 1, no, we need here 0 and this is not right. Impute scale pipeline, as I said, impute, yes, impute scale pipeline, that's also right. So impute scale get steps impute, this is wrong because get steps will not be there. This is the wrong syntax to access this particular thing. Impute scale pipe get steps 0, this is also wrong. CT 0 0 0, so CT basically refers to this column transformer. It says 0 0 0, so that means first 0 then 0 then 0. No, we can't access it. It will throw an error directly, so this is already wrong. None of these may not be right because we already have two options, right? Now if you're wondering what is impute scale, nothing, it is the name of the pipeline of the first step. Now make sure that you understand this particular thing because these are the things that will come in later weeks. It will make your life easier. Okay. Now question number 151, 152, and it's simply a trick question here, and it's an important question also. I have seen it repeated in many papers. So here it simply gives you a code, and the code is about SGD regressor. It says print reg.cof. Now one thing to note here is that this will tempt you to say that it's an array. and that's totally fine, even that this particular thing is array, and this is because you have printed this rec.cof directly, you haven't used this print statement, right? And this is very common error that you will do if you do this. Here it says print, right? And if you apply it on an array, it will simply return the array itself, that means the row vector. So this is very important that you understand this. Similarly, this also will not work because we have how many parameters? 4. So that means that we should have 4 values, 0, 1, 2. It is not there, so that's wrong. Given code will return because the data set is not given. No, this is wrong because random number can be generated and can be applied. So if you are wondering how we are going to solve this particular question because we don't have our data, you don't actually need the data. This is just a trick question to see if you can figure out that this array, when using print, will return us the array value or the row vector. Now 152, which of the following could be possible output of print reg.score? And again, this is a trick question. Why? Because they have just said reg.score. It is not given that what is the data here, xtrain or ytrain or xtest or ytest, right? So without it, how can we say that what will be the score? So it is wrong. So given code will return an error because you haven't passed any value. So think out of the box because they will trick you in these type of questions. Okay. After that, question number 153, and this is again an ambiguous question to me. Question number 154, a very good question indeed, and I think it is an important one also. Here, look at this particular relationship. What you need to do first of all is that rather than looking the data, find the actual relationship here. What it says? It says 3, so 3, that is our intercept, plus 1 into x0, so that means x0, plus 2 into x1, so 2x1. Now you can see that we have our intercept and this is our data, and 1, 2 are nothing but our weights, w1, w2, and x1, x2 are nothing but coefficient, and b or intercept is nothing but our 3, and we have equation y is equal to mx1 plus mx2 plus b. Now this same thing we are doing here. Regression 1, linear regression, fit intercept false dot fit. So here you need to understand what fit intercept does. It fits the intercept. So it says false, that means by default it will be 0 since it is false. So you will not be fitting your 3 here, it will be 0. Just think once guys, that if you have a data and your data has this connection of like this and you are passing a value through this, how can you expect that you will get a good model? You will not be getting a good model, you are actually getting a error rate, right? And this error will cause an issue. So this particular S1 score, which is the evaluation of the performance, will be low. On the other hand, this intercept is true. That means that we can fit whatever intercept we want, and since we are using the fit method, so it will automatically estimate the parameter b and it will find that it will be 3 or something closer to 3. Then that means that your line gets shifted here and you get the actual line. That means your score here will be high. That means you are performing good on this, and that's the question here, which is more likely to be true, S1 or S2. So S1 will be less than an S2 because S1 does not use intercept and S2 use intercept. So this is the question here rather than calculating the entire data on this particular code. Okay. Now we move on to 155. What will be the output of following code? Ytest, ypred, R2 score, ytest, ypred, and again I will be skipping this particular question to the last. Now 156, very important. I have seen it repeat many times. What is the purpose of toll parameter of the SGD regression in the given code below? So here toll means tolerance, and as the name suggests, it lets you tolerate some level of error. So it controls the learning rate of a stochastic regressor during training, wrong. It determines the number of maximum iteration for training process, wrong. And iter no change basically says that change in validation error not done. It defines the fraction of validation used for early stopping, that's wrong. That is validation fraction is doing this, and here it's 20%. Now it specifies the tolerance level for early stopping based on the change in validation error. Yes, this is right. So it simply says that even if the error is value less than this, no problem with that, but as it doesn't change for 5 times and the value increases by this value, then you need to stop, and we stop by using the parameter early stopping, and it prevents overfitting. Okay, so this is the right answer. Now consider the following block of code. If needed, make appropriate assumption. So score, cross validation score, estimate a linear regression. That's the clue here. Okay. X train will be training data, Y train will be training labels, CV shuffle split, which we have defined earlier. That is 5 splits 0.2 and 242. And scoring, what score can go. So in linear regression, by default it is R2, but you can use MSE, MAE, RMSE. So you just need to understand that these all are actually errors, and scikit-learn actually helps us to convert these errors to a score by just adding a neg keyword at the start. Since it is mean squared error, so we are saying that it is wrong because it's an error and we want a score. Okay, so keep that in mind. Negative mean squared error, right? As I said, so this is right. And then R2 by default is a score itself. Okay, so no problem with that, but we also use it to evaluate errors also. That's why I said errors. So error, negative R2, nothing like that is there. Accuracy and negative accuracy are for classification problems, which is actually done by logistic regression. Okay, so that completes our question number 157. Now let's move on to those questions which are actually time consuming and requires a little bit more effort. So now we will be dealing with question number 144 and 145. This question asks for Euclidean distance. It simply says that you have this particular data and you need to apply the Euclidean distance on these values, and this particular data has 4 points. Index of points starts from 0 and ends at 3. So this will be 0, this will be 1, this will be 2, and this will be 3. And you need to find the highest Euclidean distance. So those who don't know, Euclidean distance is just the distance between 2 points. Okay, and it is calculated as root under x1 minus y1 whole square plus x2 minus y2 whole square plus x3 minus y3 whole square and so on up to xn minus yn whole square. And one thing to note here is that it does not include nan values. Those are just skipped because you can't minus a nan value. And for calculating the pair, we are going to either fix this value, this value, or this value, or this value, and use it to compute the others. So it says that following pairs have highest Euclidean distance. Okay, so highest Euclidean distance means they will have the highest this particular value, right? And these x1 y1 will be nothing but x1 y1, x2 y2, x3 y3, x4 y4. And what I like to do here is that I try to separate things out. So 1 2 3 4, then 3 nan 4 1. Now here this 2 and nan will not be calculated, rest all will be calculated. So this will be like root 17 or something like that, and this is the highest value. Why? Because as I said earlier that if we have nan values, we skip the values, right? So if I do 0 and 3, you can see that only 4 and 10 will be there. So this will always be less. Here 1 nan will be skipped, 2 and 2 will tend to 0, 3 and 3 will tend to 0, and 4 minus 5 1, so that will be root 1 only, right? So this is the highest value, 0 and 1 pair. Okay, so let's look at the question. It simply says which of the following have the highest Euclidean distance. Note, take care of missing values and adjust accordingly. The option refers to the indices of the points. So it says 0 and 1, so that means we are right. Okay. Now, which of the following pairs have smallest Euclidean distance? Note, take care of missing values, adjust accordingly. The option refers to the indices of the point. Now, you already know that we have calculated root 1, but don't apply this particular nan value trick that I showed you earlier, because this nan value trick only works if the value of two rows are different. If not, you can see that it will directly cancel it and 0 square will be 0. So you will only be left with the same thing. So here 1 and nan will not be calculated, 2 and 2 will tend to 0, 3 and 3 will tend to 0, and 4 and 5 will act as minus 1, because 4 minus 5 is minus 1, whole square is 1, so a square root of 1. This 2 we get square root 36, so we can't go below this. So it means that 0 and 2 are the right pairs. Let's check if we are right. So 0 and 2. So that marks the question of the end. You can also calculate this, but I try to use these particular simple tricks to solve the questions. You are open to use those. This was the question 146 to 150. So it says print transformed x dot shape 1, and many said me that this value will be 3 and this question wrong. So no, this is not wrong. This is actually right question. Why? Because you will actually get 4 values. Let me tell you why. This impute scale pipeline also imputes simple imputer and min max scalar. So one value from here, one value from here, right, for the transformed x. Then since we are applying here, so we already got 2. Now we will use max ab scalar, again one value and again one value. So this will be 4. Okay, and this comes from the fact because you are ignoring that impute scale pipeline has these two values which are applied on 0, 1 and 1. So that's why you are getting the error. Now what will the output of following code snippet transform 3, 0? So it says third row 0th column, that means that third value. So what can be the third value? Let's check. It is applied on 0th. So 0th is only used for impute scale pipeline, right? And impute scale means simple imputer and min max imputer. So simple imputer is just to fill this nan value. So nan value can be filled with 5 plus 4 plus 3 by 3. So that's for 9 to 12, 12 by 3, that means 4. So this will act as 5, 4, 3, 4. And then we are using min max scalar. So min max scalar has a formula that you need to understand before trying to solve this particular question. That is value minus minimum value divided by maximum value minus minimum value. So just put 5 as max, 3 as min, and one thing to note here is that min max scalar actually scales your value from 0 to 1. So this is kind of very important here. So this value will go to 1, this will go to 0. So obviously this value should go to 0.5, and you can check it, right? 4 minus 3, because this value and this minimum value is 3. So 4 minus 3 divided by max value is 5, minimum value is 3. So 4 minus 3, 1 by 2, 0.5. So that means that you will actually get your answer as 0.5, right? Because third value is what? For this 0, 1, 2, 3. And many were getting 0. This was because you were ignoring the fact that these values starts from the indices 0, 1, 2, 3, as I mentioned earlier also, okay? Now we will be moving to our next question, which is question number 148. What will the output of following code snippet? It says transformed x, which is now a array or a matrix, whatever you say, and 0, minus 1. That means 0th row of last column. That means this is the first value. Now last column makes our works a little bit simpler. Why? Because last column means this particular column, right? And what we are going to use here? Ordinal encoder. And ordinal encoder does what? It encodes the data. It starts, and as soon as it encounters a new value, it adds counter to it. That means that 1, 2, 3 and 1. So 0th value will be what? This, right? So this will be 1.0 or 1. Let's check the answer. It is 1. So we are good over here. Now let's move on to our next question, which is 149, and it says what will the output of the following code snippet? Print transform 2, 1. So that means again we have matrix. This says second row index and second column, because our indices starts from 0, right? So it simply says that we need to apply all the processing on this particular column, right? So again, this is our 1. So that means that we need to first impute scale, that is do the simple imputer min max scalar, and then we need to do max abs scalar. So let me write all the transformation names: simple imputer, min max scaling, and then max abs scaling. So one thing I would like to tell you guys is that please note these formulas. It's very important. Min max scalar you already know. Max abs is just by max of mod of x. Okay. So let's first of all perform the imputation. So if we do imputation on this particular data, it will be nothing, because we don't need to impute this data as we don't have any nan value. So we will simply write this data 4 minus 1, 1, 3, right? 4 minus 1, 1, 3. This is our data. Now we need to use max abs scaling. So what is the minimum value? That's minus 1. What is the maximum value? It's 4. Now you need to perform the operations. Obviously it is time consuming, so I'm kind of skipping this particular thing. And whatever you get, you need to apply the max abs scaling to this particular method. And then whatever is the value present at this particular negation, you need to find this particular thing. And if you want, I will provide a detailed explanation in my community post. You can refer to that. It will be given in the link description. You can find that there. Okay. So this marks the end of this particular lecture. I will also be providing one more sheet which I solved in an earlier session, though I would not be able to make a video on that. Also, I hope that you will practice. All the best for your examination, and I hope to see you after examination. Till then, bye bye.